Oh, I know all about this. Ice has a lattice structure. The lattice structure describes the shape the ice takes at the temperature of 0 degrees Celsius and lower. The ice has a well-defined structure, with each water molecule having a hydrogen bond with two other water molecules. The molecule on top has both of its hydrogen atoms as part of the hexagonal structure, unlike the rest of the molecules. Each of these hydrogen atoms are connected to two other water molecules that then connect to one last water molecule to form the hexagonal structure. All the bonds between them are hydrogen bonds. Now, this type of ice with a hexagonal crystalline structure makes up virtually all ice on Earth, and is referred to as I with a subscript of H. When ice melts to form liquid water, the uniform organization of the solid breaks down as the increase in kinetic energy disrupts and occasionally breaks hydrogen bonds. The mess that is created between the bonds of water in its liquid state causes the density of the water to be much higher than that of the organized lattice structure. As some of the bonds are broken, the molecules begin to clump together in a disorderly manner, making it much denser than ice. Now let's do some calculations. To calculate the amount of energy needed to convert 32 grams of steam at 110 degrees Celsius, when it cools to ice at negative 40 degrees Celsius, we need to use this equation. Delta H is equal to mc delta T, with delta H being the amount of energy in joules, m being the mass in grams, c being the specific heat capacity of ice, water, or steam, and delta T being the change in temperature. For our first calculation, we calculate the amount of energy by multiplying the number in grams, 32, by the specific heat capacity of steam, 1.70 joules per grams over degrees Celsius, times the difference between 110 degrees Celsius to 100 degrees Celsius. For our second calculation, instead of using that formula, we'll convert 32 grams to moles and multiply that by the heat of vaporization. The third calculation looks very similar to the first calculation, but instead of using the specific heat of steam, we are now using the specific heat of water and negative 10 degrees Celsius because of the difference between 100 degrees Celsius and 0 degrees Celsius. The fourth calculation looks very similar to the second calculation, with a conversion to moles, but then it is multiplied by the heat of fusion, since it is at the point of 0 degrees Celsius. The last calculation, the fifth calculation, looks also very similar to the first calculation, but instead of using the specific heat of steam, we are now using the specific heat of ice, or 2.10 joules over grams per degree Celsius. This we multiply by negative 40 degrees Celsius because that's the difference between 0 degrees Celsius and negative 40 degrees Celsius. Now all these values will be negated since energy is decreasing when it goes from steam to water to ice. The speed, or the kinetic energy of the molecules, is significantly decreasing, and when we total all of these values, we get negative 99.6 kilojoules.